Oh, I'm fine. I'm fine. Thank you, Michaela. Thank you, everyone, to come here and enjoy with us this webinar. So today, guys, thank you again. So today, guys, we're gonna present the flow meters, the ultrasonic solution from Belimo. So it's a pleasure to have all you guys here today. And if you guys have any questions, so let us know about that, okay? So first of all, I'm gonna introduce you guys the agenda for today. So we're gonna talk about line overview, flows, specifications, installations, features and benefits for that, flow meter technologies, applications, and marketing support, okay? So to start there, I want to present to you guys our ultrasonic flow meters standalone that we already launched last year in October. So it's a new product line from Limo. So some of you guys are familiar with that, some of them are not. So let me try to introduce that ones for you. So we're gonna talk about our standalone flow product line. So we have a 1/2 inch up to 2 inch. So this is the first step for that, and probably in the end, the beginning for the next year, we're gonna have the large size. So we're gonna launch that product until or up to 6 inch. So we are able to sell that. For now, we are just able to sell up to 2 inch, okay? So here we can also see some product line overview. So here we have all those models, all those flavors for you guys. So we can also see some CV values for each line size, the flow measurement range. So we're gonna have the V minimal here. So the minimal flow that it's possible to read on that flow meters, and the maximum one. So that we call like a VNUM, okay? So here we're gonna have the differential pressure at the VNUM. So this is the differential pressure at the maximum that you can read that here. So, and we also have the output signal. So it's gonna be 0 to 10 volts, okay? So here we're gonna have some specifications for that. So we have the media. So we are able to measure and to read all the informations in chilled water, hot water, up to 60% of glycol. So all of the others medias we are not able to read, like open loops or a stent. So we are not able to do that with these flow meters, okay? So about the media temperature range, we're gonna work in -4F to 250F. The output signal, so as I said before, we're gonna work with analog 0 to 10 volts. The flow housing, and the material for that, it's a forged brass nickel plated. And this is a good point, the inlet length. So this point we have to respect that point. It's a 5D. So we have to respect before that 5 times the diameter of that. So for the outlet side, we have no requirement. So this is a good point as well. About the body pressure rating, we're gonna work 360 psi. So it's enough for HVAC applications. And the end fittings for the inlet side, it's an NPT female, and for the outlet, it's NPT male. And the flow measurement tolerance that we have that, it's a ±2%. So that starts here, it's just to state that these situations is for 77F degrees and purity water, okay? Some other kind of situations, we have a different story here, but in general, we can work with this flow measurement tolerance, okay? About the flow measurement repeatability, we're going to work plus minus 0.5%, so it's a great tolerance and repeatability. About the installation, so here we're going to see some drawings, and as I said, for the inlet length, we have to respect that, so 5D, and before the flow meters, and after that, for the outlet, we have no requirement. To mount that, we cannot install those flow meters upside down, so we have this to another requirement on that. And also to insulate that. It's possible to insulate that, but we have to be careful. So we cannot isolate the all sensor. So we have to be careful and just insulate the body part. Okay? If you insulate the sensor, we can damage or we can injure our sensor. Okay? So it's gonna be a problem for that. But all those informations you can find in the tech doc or instruction manual, so you're gonna find that in the website. Or about the installation, it's a unidirectional flow meter, so you just have one side or one way to mount that, so you have to respect that arrow that you can find in the body's part. So you're gonna see this arrow there, so you have to follow as well. If not, since it's a unidirectional one, you're gonna see, if you install that, you're gonna receive a signal, a 0.5 volts, so it's gonna be a constant one, so it means a wrong reading, okay, so wrong value for that. So be careful on time to install that flow meter. Here we're gonna see the wiring diagram. So we're gonna have a simple diagram here. So we have a common cable, the hot one, the red one, and the white for the output, for the feedback. Okay, it's gonna be a 0 to 10, and here in the bottom part we have also a table which contains some information, a good ones, I think so. It's a 0 volt, the sensor has no supply voltage, and 0.3 volts, sensor has supply voltage, but is it in arrow state? So it could be like air bubbles or different other points on your installation, okay? When we have the 0.5 volt, it means zero flow, zero percentage of the flow, or your flow meter is in the wrong direction, okay, as I said before. And the 10 volt, it's a full VNAM, so 100% of the VNAM. So in that one, you have this scale. So it's a linear characteristic, so you can put this in the graph or in some table and make this feedback for your BMS system, for example. Talking about how it works, the flow meter is very simple. It's a transit time solution here, the ultrasonic one. So here we're going to have the two acoustic mirror in the bottom part, and we have this in the left side, we're going to have the liquid flow. So we also have two emitters and two receivers that we call A and B, okay? And we also have a differential part here if you compare with the other suppliers. So we have a temperature sensor, okay? It's going to be very and really, really important for some things that I will explain. Here we have how the emitter A will send some signal to the receiver B, and on the other hand, we're going to see the emitter B send some signal to receiver A. So that's why the flow meter that we call like a transit time, so you're going to see and read each signal that you are sending, okay, in that way. So it's going to be very, very simple. They're going to read or measure the speed of sound, and they're going to take this for the flow, for example. Here, as I mentioned, we're going to have with the temperature sensor, installed that, we're gonna have these curves to, for example, to glycol compensation, to install that in a glycol applications. Okay, so here we're gonna have these curves that you don't need to care about that, because actually all those parts is in the inside of the sensor, so you don't need to care about that. Okay, it's all those parts are doing by the sensor. Okay, it's a logic part inside. So we measure with that the temperature here. It's just an example that I'm gonna show to you guys. So we're gonna measure the temperature here, and we also measure the speed of sound. So in that way, we are able to right now to read or to calculate the concentration of the glycol, for example. So we're gonna have here 50% of glycol. So that's why we have this differential part in our ultrasonic flow meters. So also we have every ultrasonic flow meter calibrated, wet calibrated, so it's very, very important to have that. And it also ensures the repeatability and accuracy for that. So this is just a summary for all things that we already heard before. So each unit is individual multi-point wet calibrated. And we also have the temperature and glycol compensation. The accuracy for that, it's plus minus 2%, and repeatability plus minus 0.5%. So it provides for sure precise and consistent flow measurement. And the good point is the ultrasonic flow meters, they have maintenance free. Why? Because we have no moving parts for that. So there is no clog possibility there, or to be affected by contaminants or some particles. Okay, so it's gonna extend the product life of our products. Okay, so also we have the analog output 0 to 10 volts, so it's gonna be easy to integrate with your BMS, anyone. And we also have a low power consumption of 0.5 watts, so it's gonna save energy for sure. Here we're gonna talk about some flow meter technologies. So in the market we can find different ones, so differential pressure, turbine wheel, magnetic, laser Doppler, Coriolis, vortex, and ultrasonic transit time. So today Belimo has two ones of that. We have the magnetic one for the EPIV and the energy valve, or electronic valves, pressure independent valves, and the energy valve for different applications for that. And for the small size, for NPT versions, we have the ultrasonic ones. So in the end of this year, beginning for next year, we're gonna have the whole line using the ultrasonic solution. So here we have some points just to compare the different solutions here. So we can see that we're gonna have, using the ultrasonic one, we can use, it's gonna be a robust one, accurate. You can also use in glycol applications, and the cost of that will be very, very good. So we can say that we have a very good cost-benefit product, okay, for the AC applications. So why use flow meters? So if you really need to know the true flow for that, you have to use the flow meters. So sometimes some people use the differential pressure for that, measuring the PT port, for example, and doing or making some math or algebra to find the flow. So here you're gonna see the real flow in your system. So it's gonna be easier and it's gonna be accurate as well. So you can also integrate that with any BMS system. So you can also detect and troubleshoot hydronic performance on that. Submeter HVAC heating and cooling usage. Some owners, they want to charge your stored store owners about some money. Why? Today it's used like split the system or charging that using the area. So if I use some area, I'm gonna pay something for that. But now it's possible to charge that in the fair way. So it's gonna be fair to charge your customers. So just reading the true flow for that. So no more math, no more algebra on it. So, and also you're gonna qualify for a high efficiency lead building point. Some applications for that. So we have the pump monitoring, the fan coil monitoring, and heat exchanger monitoring. So sometimes we really need to know if the flow is the right thing in the system, if I have the differential pressure, the flow in the system. So using the flow meters for that, you can also optimize your system. So the pumping one, so all those parts. And also, you can optimize your balancing system. Today, some guys use some devices to do that, and you have to calculate all those things. You have to use CVs or some papers for that, and use some devices to read the differential pressure. So now you don't need anything about that. So you just need to install the flow meter there, and you're gonna see the right flow, the real flow. Okay? So the other applications for that we can also use for shopping mall, commercial buildings, convention centers, and anywhere that you really want to know the true flow in your system. Okay, that's why it's really important to have those flow meters there. About the marketing support, today we're gonna have our website. So if you have any questions or if you need any documentations on it, you can go in the website www.belimo.us. So you're gonna find that the ultrasonic, the flow meters there, and you can find any documentations. Okay, so we're gonna see that our flyer that you guys can upload that, download that from here, and we also have that one in your new PGPL, so in your new price list documents. So that's all from my side. I'm sure that you guys have a lot of questions on it, and I'm able to do that to answer all questions. Thank you very much for all. And
all right. Thank you so much, Rodrigo. We do have a bunch of questions coming through. So if anyone had joined us during the presentations, now's the question and or midway through the webinar. Right now is the question and answer session. So you can type in your question. I will read your question aloud, and Rodrigo will answer it as best as possible. Now, if after the webinar you should come up with another question, you can email us at marketing@us.belimo.com, or many of you have my email address just by accepting the webinar, so you can email me directly. Rodrigo was speaking about handouts. We have 2 handouts made available to you today, and that's going to be the flow meter overview as well as the product flyer. So you can actually download those 2 items directly from GoToWebinar software. All right, Rodrigo, are you ready for those questions?
yes, I am.
Okay, first question. Is the flow meter rated for potable water, i.e. drinking water?
Yeah, not actually. It's not possible to do that because we are talking about open systems. So because the oxygen and so on, we are not able to read on that application.
Okay. Is the measurement range of the sensor well covering normal HVAC flow rates?
Mm-hmm. Yes, exactly.
Okay. Is the measurement accuracy quickly dropping off outsides of these ranges due to turbulence? So is turbulence affecting these rates?
Yes, exactly. For any kind of things, if you are talking about different temperature ranges or flow range, we can decrease the accuracy for that. So we have to. That's why we have to follow all those instructions, as well for the inlet length.
Okay. Can we get factory calibration certification documentation with the flow meters?
Yes, we have that. All our products for electronic valves that use the sensors for that, we have the calibration documents.
Okay. 0.5 W, but what's the VA rating?
0.5, it's a zero Vietnam, so it means zero flow or the wrong direction there.
Okay. Will this PowerPoint be available in PDF format? I can surely get that to you, Mr. Tong. Next question, can you talk more about the use of flow meters to calculate the heating and cooling usage?
Okay, so here we can use that as example, like if you have two temperature sensors, you can use that as well in your installation. So we're gonna have the temperature sensors, and we're also gonna have the flow measurement. So with that, we can calculate some BTU values to charge your customers, or just doing some math to use the flow as information to charge your customer. So that's why we have many possibilities to do that. But one of them, the simple one, is just to use the flow to chart that, and the other one, the good one, is to using more external two temperature sensors, and you're gonna have for sure the BTU value for that.
Okay. Why would you want to have a flow meter if I have a VIP in my system?
VIP, sorry. VIP, you said?
Yes.
Matilda?
So Shirley Costa, if you're still here, can you explain to us what a VIP is? We're going to move on to the next question, and if Shirley's still with us,
Okay.
please go ahead and answer that follow-up question. Next, is the pressure drop feet or FT or PSI?
PSI.
Okay. Does the mirror introduce a flow obstruction?
If the flow instruction?
Does the mirror introduce a flow obstruction?
Not actually. It's just a little part on that. So that's why we have a small pressure drop on it. So there is no obstruction, the mirror.
Okay. Is cavitation an issue directly after install? And if air gets in the system, does it tend to catch on the flow meter?
Actually depends. Sometimes when you have the cavitation for that, you're gonna have also air bubbles in your system. So with that, you can measure, and if you are showing like 0.3 volts, we're gonna find some error. So it's probably air bubbles or cavitation or something that we're gonna have a wrong flow or wrong measurement. So it's possible.
Okay. Does the ultrasonic meter have a pulse output for totalization or only an analog output for flow?
No, unfortunately not. Just the analog one, no pulse.
Will there be access to the remote temp sensor at a later date?
Where? I mean, this is just internal part, so we're gonna do this logic, just internal one, so we don't have the access for that information. So it's just internal logic. So the logic will do all those things. So we have no access for this temperature measurement for the sensor.
Okay. Is this recommended for open cooling tower condenser water application where debris may get in the system?
Actually, as I said before, if you have an open system, it's not possible to use that. But since the flow meter is flooded, so it's possible to use. But we have to be careful with the bubbles and all those parts of the oxygen in the installation. So sometimes we have to be careful with that. So if you have a specific project, so let me know about that, and I will try to find and figure out the best way to use that.
Is the scale factor for the 0 to 10 VDC output voltage, i.e., per the BAS point integration?
Yeah. Can you repeat the question,
Sure.
Makila?
Is there a scale factor for the 0 to 10 VDC output voltage, i.e. the BAS system in point integration?
Yeah, actually, we're gonna have the reading point. It's 0.5 to 10 volt. It's not 0 to 10. We just call like a 0 to 10 because actually you're gonna have different ones in between that. So we're gonna have 0, we're gonna have 0.3, but to reading and the scaling on it, it's gonna be 0.5 to 10. So using that values, we're gonna have you can make linear characteristic between that, or we can provide some graphs or numbers for you, and you're gonna have the feedback.
Okay, next question. Does the meter have an option to add a display?
Not yet. We probably have this in the plan, but not in this version.
Okay. Does the ultrasonic flow meter read system pressure or GPM or both?
Actually, the GPM, not the differential pressure. When we have ultrasonic flow meters, we're gonna read the flow, so no DP.
How new is this product line, and will the local distributors be likely to stock them?
Today, as I mentioned, we launched that product in the last year, so now it's available for sales, and all our distributors have this product. So if you want to buy or any other information for that, you can find that in our distributor list in the website.
Okay. How durable is the built-in sensor, and is it direct acting or indirect acting?
I forgot the first part.
How durable is the built-in sensor, and is it direct acting or indirect acting?
Actually, I didn't get the question, Makila. I didn't get that.
Okay, we'll come back to that.
Okay.
If we don't get everyone's questions, we do pull a report and we'll email you individually to make sure that we have answered your question, just for the sake of time, because I know we're running short. So I'm going to take a couple more questions and then we will close the webinar. Is there a way to also read the temperature sensor from the flow meter into the BMS?
No, because actually, as I mentioned, it's not possible to get this information for that. We're just gonna have the 0.5 to 10 volts, so we're gonna just measure or have the feedback for the flow, not for the temperature sensor.
Okay. Does the meter come with a NEMA 3R enclosure option?
No, today we just have NEMA 1, so we are working for the weather shield option for that, but we have no this option today.
Okay, and our last and final question, what is used to change voltage from AC to DC?
Actually, today we just have DC, so we have no AC, so we can just use that. You can use some transformer or something on your electrical part, but our flow meters are just ready for DC.
All right. Well, thank you so much, Rodrigo, for giving us an excellent presentation and answering all these questions. We do have a couple more questions coming through. However, we are at the end of the webinar. So if we did not get to answer your questions, look out for that email. We will be contacting you. Once again, I'd like to thank you for joining us on this webinar series. Our next webinar will be on April 27th. Same time, it's going to be air balancing a system with zoning. So that's going to go over Bulimo residential. So we will see you in a couple weeks at 1 p.m. Eastern Standard Time. Thanks, everyone. Have a great day.